I am going to discuss about unlocking intelligence and exploration of machine learning technique in AI. The main agenda of this seminar is defining artificial intelligence and defining machine learning and the relationship between AI, ML and deep learning. And we also discuss the core technique about how the machine learning model learns from data, that is supervised learning, unsupervised learning and reinforcement learning. And we also discuss the powerhouse, that is a deep learning. And we will discuss about the future trends of machine learning and also discuss the real world application. First we can go through the topic what is artificial intelligence. AI is a broad field of computer science focused on creating systems that can simulate human intelligence to perform tasks. The goal of artificial intelligence is to build a machine that can think, reason, learn and act autonomously. You can compare the artificial intelligence like the overall concept of the brain. It can be simple or complex. The AI includes everything from simple rule-based system to complex data-driven models. Next topic is machine learning. Machine learning is a subset of AI. The core idea: ML gives computers the ability to learn from data without being explicitly programmed for every task. You can think like, instead of writing a rule for every spam email, you show the program of thousands of examples of spam and 10,000 examples of spam and 10,000 examples of normal email and let it learn the pattern itself. ML is how to for achieving many of the most impressive AI capabilities. Here you can see a diagram. Artificial intelligence is the broadest concept, any machine that mimics the human intelligence. And the machine learning is the subset of AI, system that learn from data. The deep learning is also a subset of machine learning. As a specialized subset of machine learning, uses complex multi-layered neural network to solve highly intricate problem. Next we can move to the core technique, that is categorize the ML according to the learning pattern of that, which is supervised learning, unsupervised learning and reinforcement learning. We will also touch on semi-supervised learning, which is a hybrid of the first two, that is supervised learning and unsupervised learning. First we can discuss about supervised learning. The algorithm learn from dataset that is labeled called supervised learning. For example, a student's learning with a teacher. A teacher provides the data and the correct answer. The algorithm's job is to learn the mapping function that turns the input to the correct output. For example of supervised learning is training a model to identify flowers. We can feed the input of flowers image, or here with the name of each image. Here is the name is the label of image, and the model, after seeing the thousands of labeled images, the model can correctly label a new unseen image. Next is supervised learning. Key task. There is both key. There we can two key tasks, which is classification and regression. The goal of classification to predict a category. Classification and regression. The classification to predict a category. That means the classification give an answer about the questions like, is this email spam or not, or is this tumor malignant or benign. Next is regression to predict a continuous value. It will give you the answer of the questions like, what will the price of this house be? What will be the price of this house? What will be the temperature be tomorrow. The common supervised algorithm is for regression, linear regression, polynomial regression, for classification, logistic regression, k-nearest neighbors, and support vector machine and naive Bayes. The decision tree and random forest classification is used for both classification and regression problem. Next is unsupervised learning. How it works? The algorithm learns from data set that is unlabeled. The main analogy of unsupervised learning, a detective with a box of evidence. Imagine there are no pre-existing answers or labels. The algorithm's job is to sift through the data and find hidden structure or pattern on its own. Example: given a database of thousands of customers and their purchasing habits, the algorithm might discover that they naturally fall into three distinct groups. Example: budget shoppers, brand loyalists, and weekly bulk buyers. The unsupervised learning key task is clustering, association, and dimensionality reduction. For clustering, goal is to group similar data points together. Its application: customer segmentation, biology, in an image compression. The next task is association. The goal of association is to find rules that describe the large portion of the data. For the famous example is market basket analysis. Its application is Power's recommendation engine. Next task is dimensionality reduction. The main goal of this task is to simplify the data by reducing the number of features while keeping the most important information. The common algorithm of unsupervised learning is for clustering, k-means clustering and hierarchical clustering and dbScan. For association, it is a priori and eclite. For dimensionality reduction, principal compound analysis is an algorithm that we can use in case of unsupervised learning. Next is reinforcement learning. The algorithm learns by interacting with the environment. The analogy is training a dog. You have an agent, that is log in this case, in an environment, your house. The agent takes actions, sits, bark. The environment provides a reward, a treat for sit, or a penalty, a no for barking. The agent's goal is to learn a policy or a strategy to maximize its cumulative reward over time. It learns from trial and error method. Reinforcement learning example is game AI. DeepMind's AlphaGo learned to beat the world champion in Go by playing millions of games against itself. Next is robotics. Teaching a robot hands on manipulate an object or a robotic dog to walk on uneven terrain. Next is dynamic system. Self-driven car policies. When to brake, accelerate, and turn. Optimizing the cooling system in data centers. And next is the powerhouse deep learning. This is the main important application of the machine learning in a real world scenario. Deep learning is not a fourth type of learning. It is an advanced subfield of ML that can be used for supervised, unsupervised, or reinforcement tasks. The core technology is used artificial neural network, which are inspired by structure of human brain. Deep means the network has many layers. This allows to learn very complex and hierarchical pattern. Why the deep learning is a big deal? It can automatically learn features from new data. Example, it learns fine edges, then shapes, then object like fact, all on its own raw pixel. Key deep learning architecture is convolutional neural network. It is best for image and video analysis. Mainly used in facial recognition, self-driven car vision, and medical image diagnosis. Next is recurrent neural network. It is best for sequential data and used in speech recognition and stock market prediction. Next is transformers, best for natural language processing and used in generative AI models like ChatGPT, Google Bard or Gemini, and language translation. Real world application where you see ML today. In our everyday life, spam filters in your email is a application of machine learning. A recommendation engine or Netflix and Amazon. In Flipkart, you can see the recommended product of our as in our interest. This is the use of ML in our daily life. Voice assistance is also a application of ML in industry. Healthcare, which is used in healthcare diagnosis diseases. ML is used for diagnosing the diseases from medical images. In the finance sector, ML used for detecting fraudulent credit card transaction and powering vision system in autonomous vehicle, also a application of machine learning. In case of science, predicting protein folding to discover new medicines is a major application of machine learning in science field. Next is future trends. What is next? Generative AI, the trend you see everywhere. AI that create new content, text, image, code instead of just predicting. Agentic AI, autonomous agent, moving beyond simple tools to AI agents that can take on multi-step goals, plan and execute tasks on your behalf. Explainable AI, a critical field focused on understanding how a model made its decision. This is vital for trust in fields like medicines and law. Next is Edge AI, running ML models directly on small devices like your phone or sensor instead of in the cloud for faster and more private result. Next is summary. AI is the broad goal of intelligent machine. ML is a primary method for achieving AI by learning from data. ML is an also subset of AI. Supervised learning uses labeled data. The main key task of a supervised learning is classification and regression. Unsupervised learning finds pattern in unlabeled data. The main key task of unsupervised learning is clustering and association. The reinforcement learning learns from rewards and penalties. It is like trial and error. Deep learning uses complex neural network to power the most advanced task from image recognition to generative AI. Here I am going to conclude my seminar. Thank you.